Okay, so we're going to continue talking about geometric series again. AN is equal to A1 r to the n minus 1. We've talked about that previously. So let's look at find the eighth term of the geometric sequence whose first term is -4 and whose common ratio is -2. So what the eighth term is equal to A1, which is the first term, -4, times -2 to the 8 minus 1. We're using 8 because obviously n is 8. So this is going to be -4 times -2 to the 7. Well, I can already tell you this is going to be positive because this is negative. This is negative because this is odd, and this is negative times a negative, so that's a positive. Then this is 2 squared times 2 to the 7th, which is 2 to the 9th, and 2 to the 9th is 512. So this is going to be our solution for this one. I did that kind of quick. That's just because I used the power rules for exponents, and so that made this a little bit quicker than it should have been. So we have the eighth term, find A8, when the fifth term is 32, and A9 is 512. Oh, well, that's the same thing. Answer will be 256, but here we go. We're going to figure out the ratio. So we know A5 is equal to A1 r to the n minus 1, which is n is 5 minus 1. So what does that mean? That means A5 is equal to A1 r to the 4. Well, similarly, we have A9 is equal to A1 r to the 9 minus 1, which means that A9 is equal to A1 r to the 8. And so we have two things where we have A1 in them. So let's just divide by R8 and R4. Okay, so that gives us A1 is equal to A5 over R to the 4, and A1 is equal to A9 over R to the 8. Well, that means we have A5 R4 is equal to A9 R8. Well, we know what A5 and A4 and A9 equal. We have 32 over R to the 4 is equal to A9, which is 512, over R to the 8. So cross multiplication says 32 r to the 8 is equal to 512 r to the 4. So we can divide by r to the 4, r to the fourth. 32 r to the 4th is equal to 512. Divided by 32. R to the 4 is equal to 16. Fourth root. So R is equal to 2. So we've got a common ratio of 2 in this case. So if we wanted to know R8, we have A1. We don't know A1 though. But we do, okay, so here's what we can do. If we know AN is equal to AN minus 1 times the common ratio, then this is, sorry, let me fix this. I've written this incorrectly. This should be A sub n minus 1. This is the recursive form of a geometric series. Well, we know A9 is equal to A8 times R. And we know A9 is 512 is equal to A8 times 2. Then we can divide by 2, and we get A8 is equal to 256. Okay, so that's a clever way of doing it. Hopefully you guys think of ways like that when you're doing this. The next things are, write the first 5 terms. This shouldn't be that bad. A1 is 5. A2 is 5 times the common ratio. Well, that's going to be 5 times 3, 15. A3, 45. A4, 45 times 3 is 120 plus 15, 135. And then a 5. 135 times 3 is 405. And a 6 is 1215. And there you have it. So just multiply repeatedly and you'll get your answers. This isn't that difficult, I hope. I think that you guys can finish these off. The rest of the problems on the bottom of this section are things that I basically did in the other videos anyway. So if you want more practice, practice them, guys. Find something to do. We're going to get into binomial theorem next, and then that will be that for this set of videos. Thank you, guys.